Hi guys, good to see you. Today I'd like to talk about the irrationality of the square root of 2. First of all, what's an irrational number? For now, let's look at some examples of irrational numbers. The square root of 3 equals 1.7320508075. The square root of 5 equals 2.23606797774. The circular constant pi equals 3.1415926535. It's like, oh my gosh, what the heck ish things. An irrational number is an infinite decimal that doesn't repeat. This is already very confusing, so following the definition might be easier to understand and use. An irrational number is a number that cannot be expressed as a ratio of two integers. But it still seems very difficult and confusing, so let's think a little more in detail about the ratio of two integers. So now we come to the point where we define what the rational number is. X is rational if and only if x can be written as p over q for two integers p and q. Now we need to look at the set of all integers. This is the set of all integers. No decimal point, and it can be positive, negative, or zero. Let's look at some examples of rational numbers. 0.24, 5, 10 over 21. Somebody might say 0.24 is not an integer divided by an integer. Or 5 is already an integer, so it's not an integer divided by an integer. However, 0.24 can also be written as 24 over 100, which can be reduced to 12 over 50, which can be reduced to 6 over 25. And 5 can also be written as 5 over 1, which can be written as 10 over 2, which can be written as 50 over 10, etc. Now, I would like to start proving the main proposition that the square root of 2 is irrational. But before doing that, we have one last thing to prepare. So please bear with me a little longer. This is about the difference between reducible and irreducible fractions. Let's see some examples of these fractions. First, reducible fractions. 3 over 15 can be written as 1 times 3 over 3 times 5, which can be reduced to 1 over 5. 28 over 12 can be written as 2 times 2 times 7 over 2 times 2 times 3, which can be reduced to 2 times 7 over 2 times 3, which can be reduced to 7 over 3. Then irreducible fractions. 3 over 5 cannot be reduced any further. 49 over 12 can be written as 7 times 7 over 2 times 2 times 3. But this cannot be reduced any further. Negative 28 over 15 can be written as negative 2 times 2 times 7 over 3 times 5, but this cannot be reduced any further. These fractions cannot be reduced any further because the numerator and denominator have no common factors. Finally, we are ready to prove the proposition that the square root of 2 is irrational. Now let's prove that the square root of 2 is irrational. Let's see the proof. Assume that the square root of 2 is rational. Then square root of 2 can be expressed as an irreducible fraction p over q for two integers p and q. Let's call this equation E1. By multiplying both sides by q, then we get the equation square root of 2 times q equals p. Square both sides of this equation, then we get 2 times q squared equals p squared. Let's call this equation E2. We can observe that the p squared is a product of 2 and some integer. This means that p squared is an even number. So a question arises here. Can we say that p is even if p squared is even? Let's check it out. If p is odd, then p can be written as 2s plus 1 for an integer s. Then p squared equals 2s plus 1 in parentheses squared. which equals 4s squared plus 4s plus 1, which can be written as 2 times some integer plus 1. This is an odd number. This contradicts the assumption that the p squared is even. Then p has to be even. Then p can be written as 2s for an integer s. Let's call this equation E3. By substituting 2s in equation E3 for p in equation E2, then we get 2 times q squared equals 2s in parentheses squared, which equals 4 times s squared. By dividing both sides by 2, then we have q squared equals 2 times s squared. This means that q squared is even because this is a product of 2 and some integer. For the same reason that if p squared is even, then p is also even. Q also has to be even. Then q can be written as 2t for an integer t. Let's call this equation E4. By substituting 2s in equation E3 for p in equation E1, 2t in equation E4 for q in equation E1, then we get the square root of 2, which is defined as p over q can be written as 2 times s over 2 times t. We can see that this is reducible. Then what's wrong with it? Remember that the fraction p over q is defined as an irreducible fraction. This contradicts the irreducibility of the fraction p over q. So what's the root cause of this contradiction? This contradiction arose from the assumption that the square root of 2 is rational. Therefore, we can conclude that the square root of 2 is irrational. The proof is complete now. Thank you so much for watching this video until the end. I really hope this video will help you deepen your understanding of the irrationality of the square root of 2 and its proof. I look forward to having fun learning mathematics with you in the next video. Have a great day.